Good morning, everyone. So in the last session, we started about the internal implementation of this particular hash map here. So first we discussed about the constructors here, and later we started about the each and every method. So main purpose of this particular hash map, what exactly it will do here. So hash map basically it is going to use the hash table to store this particular respective information here. Getting the point. So HashMap is the first class it is implemented from the map interface. So finally, what you are understanding here? So here, the HashMap internally, it is going to use the hash table to store the map related information. Getting the point. Along with this, so it is allows the execution time. So whenever we are trying to work with this particular get method and put method, so it will give you the little bit faster time because it is going to use the hash code of the key, and based on the hash code it is going to store in the respective index location, because internally it is trying to use the node array concept here. So this is we need to understand very clearly. Now yesterday we discussed about the first method called put method. Here, what exactly the put method is doing? First, the put method internally, it is calling the put val method, and the put val, first it is generating the hash code based on the key. And once it is generated, now what we are doing is we are trying to find out the hash code, and we'll try to find out the index location. So once we identify the specified index location, now we are going to insert the record into the specified index of the node array. So this is we observe. Okay. So yesterday, what is the capacity we discussed here? The capacity we discussed as a 16. So we can insert the 16 elements here. Now, whenever we reach to the 12 elements here, so this is the threshold we are having here. Now, whenever we are having this particular threshold, what exactly it will do? It will try to create a bigger bigger node array, and it will copy the existing object. It will give the space to insert the new records. So we'll see what exactly the threshold will do now. What exactly the threshold will do now. So to understand this, what we can do, we need to insert the few more records here. We need to insert the few more records here. So now you can see. Okay, so we'll try to change the keys here. So this is the key 2, and we can come up with the key 3. Okay, so these are the 14 keys we inserted. Now here, what we can do, we can change the random values. So just I want to give. So here, now what I'm doing here, I'm trying to change this particular object here. So here, this is the 12 record. Now what we can do, I'm trying to put a breakpoint here. We'll debug the code now. So because we are having a threshold here. So whenever we are having the respective threshold, what we need to understand, how it is going to create a bigger node array. Okay, so now I'm trying to start here. So as of now, you can see these are the 11 records are inserted here. So this is the 12 record we are going to insert here. Now go to this particular 12 record here. Now this is the put value here. Now I'm trying to generate the hash code here. So the hash code will generate here. Now we coming back to here. Now we are under the put value. So now here you can see what happening. What is the table we are having? Currently we inserted 11 records here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So 10 records we inserted here. Now if you remember carefully here, how the records are stored here. So what is the the order of this particular object storing. Now you can see first record we suggested. So now you can see second record we got as a key 11 here. So why we got as a key 11 here? Because here compared to this particular key one, so the second index location we identified based on the hash code. Now you can see 54329 876. So the order, whatever the order we inserted, we did not get the same order because of hash code. So hash code will play very important role here. So finally we understand here. So table dot length. What is the table dot length we are having? So that is called 16. Now this condition is not satisfied. We are not going to call the resize. So when we are going to call this particular resize here, so here you can see here, this is the new record. This is the new record we are trying to create. So what is the index number? I value 2. So how we get this particular I value 2? Based on this particular logic here. Based on this particular hash code and n-1 logic here, now we got as a second index location. So now we inserted the second index location. Now if you see here, earlier whatever we have, go to this particular tab. Now here you can see first key, and earlier we have as a key 11, but now we replaced with this particular key 12 here. Key 12 here. So this is the way the values are going to be inserted here. So 1 and 1 2, something like 11 we inserted here. Now we'll go to the second record here. We are coming out of this. Now this is the 13 record we are trying to insert here. Now observe carefully. This is the hash code, and now we are out of this. Now we are under the put value. Here you can see the hash code. So we are getting as a minus values. We are getting as a minus value. So whenever we are having minus value, so what is a hash code like index location? We are able to see 13. We are able to see 13 index location. So earlier, so now here you can see 13 do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 we are having. So there is no 13. But here these records are not inserted in the sequence order. These records are not inserted in the index location is not a sequence order here. Okay, so earlier record we inserted in the second index location. This record we are trying to insert in the 13 index location. So this is very important here. We need to understand here. So now, so one more record I'm trying to insert here. Call the put value here. So call the hash code, come out of this and go to this particular put value. Now finally, now what I'm doing is I'm trying to find out the index location. So this is something like a 12. Earlier we got as a 13. Now this record we are trying to insert in the 12 index location. So we inserted and we are coming out of this. We are coming out of this. Now, so what we need to understand, whenever we are trying to work with here you can see the hash map is increased here. Earlier we have a 16, but the size is now increased here. Get the point? Here you can see 13. Here you can see the size is now increased here. So how it is increased here? What you understand here? If you go to here, so here we are not doing anything here. Here we are not doing anything here. So simply we are working on this particular node object creation. Okay, but where it exactly it is changed this particular value here. Where exactly this particular object is. Earlier what we understand here, so 16, but currently you can see 32 objects we can store here. So something like the size is increased automatically. So whenever we reach to the particular threshold here, the size is now reached here. So let's observe one more time. Now we'll understand the one more time with here you can see. So we'll try to debug in the which index locations it's trying to insert here. So from the first record onwards, we'll try to debug here, so that we'll understand if we are getting the same hash code. So what exactly it is going to do this particular insertion here. Now, okay. So what I will do here, I'm going to put a breakpoint here, so that directly we can go to here. Okay, sorry. We can run one more time. Okay, this is coming from the different location. So now put a breakpoint, and here you can put a breakpoint here. So we can debug here. Now you can see, so main map. So this is, we are only calling this. Now understand here, what is the hash code? So this is the hash code. Now if you see this particular table, first record we are inserting. So we are calling the resize here. We are calling this particular resize here. Okay. Now here we resize. So how many record we can insert here? Carefully observe. Here we are able to see 16. Here we are able to see 16. So by default, we can insert the 16. Okay. Now we already identified the threshold is 12. So same logic here. The logic, it is not going to be changed here. Now here we need to understand the hash code. So hash code, we are going to be stored in the 0 index location. Okay. So index is 0. For the first record, index is 0. So now we understand here. Now what we are doing is, we are inserting and we are going back to the second record. Now you can see, this is the second record we are calling. Okay. So now here you can see, so this condition will become false. So this is we already identified. Now the second record, it is stored in the 7 index location, because here you can see I value 7 we are getting. I value 7 we are getting. So it is going to be stored in the 7 index location. So now we understand here. Now third record. Now you can see third record. So this is the line it is trying to call the third record. Now, so for the third record, what is the I value we are having? I value 6 here. So that it is inserted in the 6 index location. 6 index location. So now fourth record. Fourth record here you can see 5 here. Fourth record, it is inserted in the 5th index location. Okay. Now, so now sixth record. Sixth record, I value 4 we are having. Okay. I value 4. Now, so seventh record. Now here you can see the seventh record, it is inserted in the 11 index location. 3, 4, 5, 6. Okay. So 6 are completed. 1, 2, 3, 4, 5, 6. Yeah. So 6 record inserted. Now we'll go for the 7th record. Now you can see the 7th record. So it is time to insert it in the 10 index location. Okay. So now we'll call the same way. 8 record here. So I value 9 we are having. 9 we are having. Okay. Now after that, again we can insert here. So what is the n value? N value we are having 16. So carefully observe, n value we are having 16. So here we are having 16. So as of now, so still here we are inserting 16 records only. Okay. So now this is what we need to understand here. Okay. Now after that, okay, so no need to change it. 16 we are having. Okay. Now, so one more record we need to insert here. So here if you observe carefully what we are doing here, this is important here. This condition is also important. What is the size we are having? Size currently 8 here. So it will become 9 here. Now what is the threshold we are having? 12. So whenever this particular condition and threshold is satisfied, what we are doing? We are calling the resize. So whatever the resize we called here. So here also we are calling the same resize. Getting the point? This is important here. Now whenever it is satisfied, we need to understand here. So as of now, it is not satisfied. So we are getting as a false. Now how many record we can insert? This is the 9th record we are trying to insert. What is the I value? Now if you remember, here we are getting the I value 0. Already one record is inserted. Already one record is inserted in the 0 index location. So again we are getting a 0. Now what you understand here? So hash code is same. Getting the point. So in the same index location, we cannot insert the 2 records. So if you remember, whenever we are having, let's say this is a I value 0, I given as a 10. So same I value 0, and here I'm trying to giving as a 20. What happens basically? This 20 will replace this particular 10 here. This 20 will replace this particular 10 here. Getting the point? So this is what we need to understand here. But here, what exactly it will do now? So we need to understand whenever we are having a same index location. Whenever we are having same index location, so what exactly it will do now? What exactly it will do now? Now here, normally this is a condition it is going to be satisfied, but whenever the high value it is 0, it is not satisfied. So we come out of this particular else part. Here what you need to understand here, hash code, p dot hash code, both are same. So this is the current hash code we are having, 40464, and what is the p? Is a earlier object. If you, here you can see earlier object, what we are having the hash code, so 912. This hash code 464 and 912, both hash code are different here. Both hash codes are different here. So what we are doing here now? Okay, what we are going to do now? So here you need to understand here this hash codes are different here, and p dot key. P dot key. What is the p dot key? The p dot key, I think key one. So we given as a key one. So this is a key one we are getting. But what is the current key? It is a key 10. It's a key 10. So both are not going to be satisfied here. So now you can see what we are doing here. So this if condition is not satisfied. And here we are working with the tree node. It is also not satisfied. We are, so this particular P, basically it is a node here. Okay, it is a node here. It is not a tree node here. Okay, this else if also will not satisfy. So finally, we come out of this particular else here. So what we are doing here? Here you need to understand here, very important here. Here we come up with the for loop here, and just we are having the initialization and increment part, but there is no condition. There is no condition. So when we are going to check the condition, here we are checking the condition. If any one of the conditions satisfied, we'll break the particular program here. Okay, so now you can see, so bin count is 0 and we are incrementing it, and here p dot next, p dot next. So p dot next, as of now we did not inserted any record, so it will return as a null here, because the first record what we are having now, if you remember, this is the first record. So hash code key we are having key 1, and the value something like a member object we provided, and next node. Next node, basically it is a null here. As of now it is a null. Getting the point? So this is a 0 index location it is inserted. This record is inserted in the 0 index location here. Okay, so now what we are understanding here? Now, what we are understanding basically, here we are understanding the important concept called, whenever p dot next is null, what we are doing. So p dot next, carefully observe, p dot next is equals to, we are calling the new node. We are calling the new node. So here also we are going to call the same new node here. Here also we are calling the same new node. So finally, what you understand here, whenever we are trying to insert in the same index location, whenever we are trying to insert in the same index location, so now what happens here, this next to, so normally it is going to create a node like this, hash code and key. What is the key we are going to pass here? Key 10 we are passing here, and again we are going to have a member object, and this is the next node. Currently the next node is null, so this next node now it is pointing to this particular object. How we are making the initialization here? So p dot next, this p dot next you need to understand here. This p dot next you need to understand here. So p dot next is equals to new node. So finally we are trying to create a new node, and we are assigning into the existing node. We are assigning into the existing node. So p basically it is the existing node. P basically it is existing node. Now we are assigning the newly created node. So this is the way, even though the indexes are same, what we are doing it. So with the help of this particular next node reference here, we are trying to create a new node here. Okay, this is what we need to understand here. So this is very important information we are trying to understand now. Okay, so we discuss here. So finally, so the p dot next is 0. We are trying to create a new node, and we are trying to add here. So what is the bin count currently we are having? 0. And what is the threshold we are having? 2. Sorry, Okay, 8 we are having. So 8 minus 1, it will become 7. So this particular condition is not going to be satisfied. So what we are doing here, we are coming out of this particular section here. So simply here we break this, so we come out of this particular space. Okay, so once we break, now we are out of this here. Now what is the E currently? What is the E currently? E, whatever the P dot next we are having, so that we initialize into this particular E. So now if you see this particular E value, whatever we are having here. Let me see, just to print this particular E here. So result we are getting as a null. Now what is the condition we are having? If the not equals to null, we are going to do this particular piece of code. In our case, so it is also not satisfied. So finally, what you understand here, even though one more record we are trying to insert it in the same index location, but here what we are doing is we are not replacing the existing object here. Okay, we are not replacing the existing object. What we are doing, we are making the node relation. How we are making the node relation? So the first node initially, what exactly it will do here? It is trying to, okay, it is trying to create a next node reference null. But whenever we are having the, so same record we are going to insert in the, so different record we are going to insert in the same index location. So in this case, the existing object next to reference, it is going to point into newly created node here. Okay, so this is very important, we need to understand here. So now another important section here, so mod count we are increasing. So what is the size currently? So the size will become 10 here. Okay, so threshold we are having 12. So now this is the important part we understand here. So secondary record we need to understand here. Like mostly I think this is the 11 record we are trying to inserting here. Now what is the index location we are having? So what is the index location we are having? I value 3. So as of now we did not get the 3. As of now we did not get the 3. So this is a 3 index location, it is going to be inserted here. Okay, so now we understand here. Now here you can see, so what is the I value we are having? I value 2. Now here you can see, so I value 2 also, it is the first time we are trying to inserting a record here. So now we understand here, this is also inserted successfully. But what is the size we are having currently? 11. So what is the threshold we are having? 12. Now if you see this, it should be the greater. It should be the greater here. So now you can see in our case, the resize method, it is not calling here. Now, so this is a 13 record we are inserting here. Now if you understand here, so what is the I value? I value 13. I value 13. So only one record we got as a same index here. So remaining we are trying to insert in the unique index locations here. So now you can see we inserted. But currently you can see this condition is now satisfied. Which condition here? So this particular if condition. This particular if condition is now satisfied. Getting the point? Because threshold value is 12, but size currently we are having 13. Currently the size we are having 13. So now we are reached the particular threshold here. Whenever we reach to this particular threshold, now what we are doing is we are calling the resize method. We are calling the resize method. So what exactly the resize method will do now? What exactly the resize method will do now? So here, what you need to understand here, the internal implementation we need to understand here. The internal implementation of this particular resize we need to understand here. Okay, so now here you can see I'm calling this particular resize method, will debug this particular resize method. So old table. This is the old table. So currently how many record we inserted? These many record we inserted with a different index location. Okay, so if you see this, the first key one, what we are having, so this is a key and this is a value. Okay, this is the key and this is the value. But another important section here, what you need to understand, if I'm expanding only value, but where is the next here? Where is the next here? So I will show you how this particular next it is going to be working. So we understand the table now, and old table, if it is equals to null, it will do the 0. Otherwise, old table dot length. So the length we are going to get as a 16. So this is we understand here. Okay. So old threshold, old capacity is 16, old threshold is 12. Now new capacity, new threshold as of now 0. So what we are going to do now? What we are going to do now? Here we are going to check here old capacity if it is a greater than 0. Old capacity if it is a greater than 0, it will do this particular piece of code. Now what we are doing here? Now you can see what is the old capacity 16 and maximum capacity. What is the maximum capacity? So this is the maximum capacity. So now it is not going to be satisfied here. This if condition, it is not going to be satisfied. So we'll go to the else if. So what we are doing here, new old capacity, we are assigning into the new capacity based on the maximum capacity. And so old capacity, default capacity. So default we already identify 16 and old also we are having 16. So it will try to find out the new threshold. So what is the new threshold we understand here? What is the new threshold we are having? 24. New threshold. Earlier it is a 12. Now it is a double. Now it is a double. Getting the point? Now, so what is the capacity we are going to get? Threshold we understand here. So threshold we understand here. What is the new capacity? 32 we got it. Okay. New capacity we got as a 32. So it is also double. Earlier initially 16. Now it is double. Same way the threshold earlier it is 12. Now it is double. So 24. Okay. So now what we did? So earlier initially this is a small node array we created. Now we are going to create a bigger node array. So the size, the length, something like 16 we are having. 16 elements we can store, and this is we can store as a 32. Okay. So see how the hash map internally it is expanding. So this logic we are not yet implemented explicitly. So this logic internally it is implementing it. Okay. So we observe this. So we created like we are trying to create a node array here. So this is the part we already discussed here. It will try to create the node array with a new capacity called 32. 32. Okay. So now understand here, this is created new table. Now what we are doing here? So new table we are assigning into this particular table. But here the table, if you observe, these many objects we are having. Okay, these many objects we are having. But in the new table you can see, so nothing. So all the objects are empty. Whenever I am trying to initializing into this table, what happens basically, the whatever the current object we are having, all the objects will become null. All the objects will become null. So now you can see the table also null. The table also null. But where we are going to get the existing record? Okay. So how we are going to get the existing record? So we are getting the existing record with the help of this particular old table. So here initially if you see here, this is the main table we are initializing into as an old table. So in the main table we don't have a records. Now you can see all are empty, but you can see the old table. So still we are having a records here. Okay. So still these many records we are having here. So these records now will process and it will copy into the newly created node array. So now you can see, so old table not equals to null, and here, so int j is equals to 0. J is the old capacity less than the old capacity, and j plus plus. It's a simple for loop we added here. Now what we are doing here we are checking here. So what we are checking here? So old table j, we are like we are loading the record. Okay, this part basically it will load the record and initialize into this particular e, and we are checking not equals to null. And we are checking not equals to null. So whatever the record we are going to load successfully, those record will process here. Whenever the record will get as a null, it will not process. So first record will load, because in the 0 we have a 2 records. In the 0 we have a 2 records. Now observe what exactly it is doing. Okay, what exactly we are doing. Now this is the record we have. This is the key and value. Key and value. Now what I'm doing here, in the old table, I'm making the null. In the old table, the 0 index location I'm making as a null here. Okay. In the 0 index location, I'm making as a null here. So this is what we need to understand. And here, so e dot next, because we are having a record here. E dot next also we are having a record. Now you can see key 10. Next also we are having a record. So this is only I suggested whenever we are working with a node array, it will do the node relation here. Okay. So in our case, this is having record. It will not satisfy here. It will go to the last here. Now you can see now. So this also will not satisfy. So finally we reach to the else block. So what we are doing is next. So e dot next is equals to next. Where do I declare here? Here I declare the. Okay. So now next record also I loaded here, and e dot hash old capacity. E dot hash and old capacity. If it equals to 0, it will do this. Otherwise, it will do the so else block here. So here now what we are doing, this is the head record we are keeping, and this is the particular piece of code we are going to do the same here. Now you can see while loop we are having, we are doing the so internal changing the values here. Now finally we are inserting here. So this is the newly created table. This is the newly created table here. Now what I am doing here, I am trying to inserting. So j plus old capacity is a high head. Okay. So key one. So same record we are going to insert here. So this is we can do here. Now, so keep on, it will insert the record into this particular index location. So this is the new table. Now you can see new table as of now 3 records we inserted. From which table we are copying? Old table. Okay. So this is the way it will copy the existing records into a new table. It will try to give the bigger space because 16 we are having earlier initial object, but currently it is increased to the 32. So this is what we need to understand here. So this is the way we are inserting the record. Okay. So this is very important, the example we discussed. So still any questions? So anyone having any questions? How the Hashmap internal it is working? Okay, so this is very important example we discuss here. Now we understand how the put method it is going to be work. So same way we can work with the put all method. So here you can see put all method. So what exactly the put all method will do? It will work as a collection, like multiple record we can pass as a parameter, but internally it will do the same. It will call the same put method. It will try to insert the record here. Okay, so now another method, size method. So size and is empty contains key. So size and is empty. So what exactly the size method will do now? So to understand this particular size is a simple here. So hashmap dot size we are calling. Whenever we are calling this particular size, what is the size? It is a variable. So the variable, whenever we are trying to inserting the record, for each and every time we are incrementing the value. We are incrementing the value so that how many times we are going to insert the record, for all the times this particular records are going to be, this particular variable count it is going to be increased. So based on that we can identify how many records are inserted into this hash map. Okay, so same way is empty. You can see if the size equals to 0, if the size equals to 0, so we can understand this the hash map contain the empty record. But currently this size is having around mostly 12 or 13 record. So because of that, it is not going to be empty here. Okay, it is not going to be empty. Let's see the how many record we inserted. How many? 14 records. Okay, so 14 records we are having. So to understand is empty, how it is going to be work, so simply, so 14 equals to is 0. 14 equals to 0. So this is what we need to understand here. This is what we need to understand. So whenever the size 0 equals to 0, this will become true. Other than this, any case it will become false. Okay, so if you are making 1 equals to 0, this also will become false here. This also will become false. So this is what we need to understand regarding the is empty. So just we are comparing. So left side variable with the right side value. The left side value and the right side value both should be same. Then only the condition will become written as a true. Otherwise, the condition will become false here. Okay. So these are the important section we need to understand regarding this particular is empty. So what exactly the third method, something like a contains key, will do now. So we need to understand the contains key here. Okay. So to understand this particular contains key, what it will do now. So here I'm going to write hashmap dot contains key. So key, what is the data type we are having? Like what is the generic type we provided here? String we provided. Okay, so we can provide the string here. So finally, now I'm going to give as a 20. Now I'm going to give as a 20. So what is the value basically we'll get here? We'll get as a true or false. If the key is available, we'll get as a true. So otherwise, we'll get as a false here. We'll get as a false here. So now let me let me run this particular example, like put a breakpoint here, and we are going to be run in the debug mode here. So I'm running in the debug mode. So remove this. No need to discuss about the put method. We already familiar with this particular put method now. Now finally, I'm calling the contains key. So what exactly the contains key will do now? So if you understand here, so this is the key we are passing. This is the key we are passing, and here what we are doing here. So here we are doing the hash code. Okay. So here we are generating the hash code first. For the given key, first we are going to generate the hash code. Now, so hash code is going to generate it. After generating the hash code, so what is the next step we are doing? What is the next step? We are calling the get node method. We are calling the get node method. So what exactly the get node method will do now? What exactly the get node? So this is a get node method. Now, what is the table we are having? Currently, the table we are having here, so these many records. So 14 record we inserted so far. 14 record we inserted here. Now another important section, table we are initializing into this particular tab, and if the table length, if it is greater than 0, we are going to process. So after that, what we are doing, we are checking this particular condition. Now you can see this is very important. So why we are getting null here? Why we are getting null? Here, if you understand, this piece of code is satisfied. This particular piece of code it is satisfied, but this piece of code it is does not satisfied. Why it does not satisfy? Because here what we are doing, based on the hash code, we are going to generate the index location. Based on the index location, we are going to load the objective. Okay, the value now we are initializing into this particular first here, and the first it should not null. Okay, so this particular line basically we are doing the 4 operations. What are the 4 operations? First operation, we are we are trying to find out the index based on the hash code. So we find out the index. Based on the index, now we are loading the record. So second, so once we load the record, we are initializing into the first variable. Okay, third, and the first variable it should not equals to null. Then only it will enter into this particular block. Otherwise, it will come out of this particular. It will come out of this particular condition. So in our case, what we understand here. So the first step is do. So second step also do. Third step is completed. Whenever we reach the fourth step, the first record is null. Okay, so finally what we are checking here we are going to check this. So first not equals to null here. Whenever the record is first not equals to null, it will become true. But in our case, the first is basically it is a null. It is a null. So how we are saying it is a null? Because based on the hash code, okay, based on the hash code, now we are trying to load the record. So what is the hash code we observe? This is the hash code. But what is the key we given? So key 20. So as of now, we did not inserted the key 20. So here you can see key 1 to key 14. Key 1 to key 14. So here what you understand here, so 1 to 14 we inserted, but there is no 20 here. Because of that, now the contains key, it's simply returning as a false. Simply it's returning as a null. If what we are having, if this entire get node method, it is not equals to null, then it will become true. Otherwise, it will become false. We are trying to return as a null here, so that it will become a null here. So this is what we need to understand here. This is what we need to understand here. So now we understand here contains key hash map. So this is the record we are able to print. So now I'm going to change it. I will change as a 14 because this 14 key now it is available. This 14 key now it is available. Let me run the same example one more time. Now we'll understand here how these particular records are going to be loaded. Okay, so contains key. So again we are going to generate the hash code and get node I'm calling. Now if you understand here, so now we'll enter here this particular condition we are trying to check here. So now you can see we come out of we enter into this particular condition. So earlier directly we written as a null here. Directly we written as a null. So what you understand here, based on the hash code we'll generate the index location. So based on the index location we'll try to load the record from the node array, and if the record is available we'll enter. Otherwise we'll come out of this particular condition, simply we'll return as a null here. So this is the contains key. Internally the get node method is implemented. Okay, so what we are doing here, so this is something like a first dot hash. What is the first record we are having? So something like so while inserting the record, while creating the node, we are passing the hash code, key value, and next no reference here. Okay, so same section here, first dot hash and the current hash. So now you can see what is the first dot hash we are having here. So this is the first dot hash. So minus 11 34 740 468. So now if you see this particular value, now it is matching with this particular value. Okay, this particular hash code and this particular hash code both are same here. Both are same. So now what we are checking, first dot key. What is the first dot key? So what we are having, key 14, and current key 14. So both are satisfying here. Okay, so this is we can understand. So finally, simply we are trying to return the first record. Getting the point? So here we are going to check the hash code we are checking, key we are checking, and if the key not satisfied, we are going to check this particular equals method. Okay, double equals operator we are checking, and equals method also we are checking. So safe side we are checking the both condition. So whenever it is satisfied, simply the record, whatever the record we loaded, the record we are trying to return here. So it's a simple, while inserting, loading, deleting, anything what we are doing with help of this particular hash map, internally it is going to work with a hash. So without the hash code here, it is not going to do any operation. So this is what we need to understand here. Okay, so now we are trying to return as a first record. So this record it will try to return. So whether the record is available or not, how we are going to check is simply it will try to return as a true or false. Simply it will try to return as a true or false. Now you can see true we are getting. Now you can see true we are getting. So whenever we are getting true, what we can understand is the record is available. So now I'm going to make as a 20. I'm going to make as a 20. So now, so same example I'm running here. Now you can see we are getting as a false. So that the record is the given key, it is not existed into this particular hash map. Okay. So now we'll discuss about the contains value. Contains value. So what exactly the contains value will do now? Contains value. So here what we need to understand here, we need to provide the what is the value we provided, member. So we need to create the member object. Now what I'm doing here, so I'm copying this particular member object here. I'm copying this particular member object here. Now the department I'm changing. What is the department we can give as a something like a sales. Okay, so here instead of giving this hash map 2, so I'm going to change as a hash map 3. Okay, so now understand here. I'm going to run as a contains value. How the contains value it is implemented. So we discuss the contains key. Now I'm calling the contains value. Okay, contains value. So now here you can see what we are doing here. So here for the contains value, we are not checking any hash code. Okay, here we are not checking any hash code. So simply we are we are loading the table and I'm initializing into this particular tab and we are checking the size. Okay, so both conditions should satisfy here. And here, so each and every record we are repeating. Each and every record here we are repeating. So whenever we are repeating the each and every record, what we are going to load? Only we are loading the value. Here you can see we are not loading the key, just we are loading the value. Okay, here, so here we are having a node here. Directly we are connecting the node. From the node only we are trying to perform the operations here. So now we understand here. Now we understand here. Now here you can see there is no initialization. Only we are having condition and here we are doing the next here. Here we are doing the next. Now you can see, so E, whatever the E we are having currently null here. Currently null we are having. So why we are having null here? The first record, okay, from this particular E, whatever we are having, because it will try to repeat the 32 records here. It will try to repeat the 32 records. So in the 32 records, it will keep on repeat and keep on checking the condition. First record is null, so second record is checking. So second also null, third also null, fourth null, okay, so fifth null, and sixth also null. Now currently what we are having here, so E still is E value null and E value null. E, so here you can see we are having a record. Here we are having a record. If E not equals to null, we'll enter. He is entering. Now, so what is the value we passed here? So what is the value we passed here? This is the object we passed here, member ID 792. And here we are checking E dot value. E dot value. So what is the E dot value we are having here? Now this is something like 792 hash map to department map. Department map. But what we are checking here? Here we are checking the with a different object here. So whenever we are adding here, now if you see value not equals to null, here we are going to call this particular equals. Whenever we are calling the equals, which equals it is going to be called here? Which equals it is going to be called here? The equals it is going to be called in our class. Okay, the member class equals method it is going to be called. So now you can see, now if we are under the member class. We are under the member class. So this is the equals method we override it. So observe carefully how the equal and hash code methods are playing an important role. How the hash code and the equals method is playing an important role. Getting the point? This is very important. We need to understand here. So now you can see we are checking the each and every object and all the objects we are checking here, like ID, name, and department. Everything we are checking. So finally we got as a false. Finally we got as a false. So this is a way it will keep on checking the 32 records here. It will keep on checking the 32 record. In our case, any record it is not going to be satisfied because we given the department as a different. We given the department as a different here. So it is not going to be satisfied. So simply we'll get as a false. Simply we'll get as a false here. Okay. So now you can see I'm trying to make false here. Sorry, I'm trying to print the println statement so that we can understand what is the value we are going to get here. So both we are getting as a false. Key we are getting as a false as well as the value also we are getting as a false. So because the key we given as a 20, the 20 key it is not available. So at the same time, the value department to sale we don't have here. So we have a department, something like a map, and the hash map we are having two. Hash map we are having two, so that these records are available. So that these particular records are available now. Now again I'm calling so that we can understand how this particular, sorry, we can understand how the contains value is implemented internally. Okay, now you can see This is the table we are having. Now we are checking. Still we are having null, null, null. So we need to find out which record is going to have a object here. Which record it is going to have a object. So here we are having an object here. Now what we are checking basically, the member, it's same. Whatever we given, the department, ID, name, everything is same. So we'll see here, e dot value, we are passing into this particular v variable here. And after that, now what I'm doing is, I'm going to check if the value not equals to null, I'm going to be called the equals method. Now we are under the equals method. Now we are under the equals method. So now what I'm doing here, so here you can see ID matching, name matching, department matching. Department matching. So all are matching. Here you can see true we are getting, and one more true we are getting, one more true. So finally it is returning as a true. So now we are trying to return as a true. So the given object is available. The given object is available. So simply we are returning true. So this is now going to be written. The first key is false, but the value is available. So it is trying to return as a true. So finally, what we are understanding is, by using the contains key, whether the given key is existed or not, we can check. By using the contains value method, we can check the value is available or not. Okay. So these are the contains key and contains value method. So same way, so get we are having. So get what exactly it is doing now. Get to what exactly it will do now. To understand the get method, what we can do here. So here hashmap dot get method. But get method, what is expecting here? It's expecting key here. Okay, it is expecting key. Now what I'm doing here? So simply I'm going to give as a key 20. Simply I'm going to give as a key 20. So we'll understand here, whenever I'm giving this particular key, whether what is a value it is going to be written. Okay, key I given, what we are going to expect here? Only value. So what is the logic it is implemented for this particular get method? Now call the get method. Now observe carefully. So hash code we are calling and get node. Hash code we are calling and get node. Now what you understand here? The get node internally it will try to return as a node here. But when it is going to be written as a node here, so when this particular condition. So you can see this condition should satisfy, and the first condition also satisfy. So then only it will return the node. Otherwise, simply it will return the null. Okay. So just now we discussed the get node. When we discuss it, contains key. Okay, contains key. So whenever we are trying to work with this particular contains key, the same logic we implemented. Okay, same logic. Internally, it is going to call the same logic here. So this is we need to understand. Whenever the get node, it is going to be written this node array. What we are doing here? So here we are checking e dot value. E dot value we are checking here. Okay, if the entire node it is equals to null, we'll return null. Otherwise, we are going to return as a e dot value here. So simply, just we are going to return the value here. But in our case, the key 20 it is not available. The key 20 it is not available. We'll get as a null here. We'll get as a null here. So to understand here, now what I'm doing here, I'm going to print this. Okay, I'm going to print this particular get method. So now you can see I'm running with without the debug mode here. So null we are getting. So why we are getting the null here? Because the given key it is not existed into the hash map. So the records are not available. Simply it will try to return as a null. Now whenever I'm giving as a 14, whenever I'm going to give as a 14, not only 14, you can give any number. So the key it should exist. So map value we are getting. This is the value member only we provided as a value. So this is what we need to understand again. So still any question like put method, size method, contains key, contains value, get method. Any questions? Okay. Now if you don't have, so the last method we can discuss here, remove method. Remove method. So what exactly the remove method will do now? To understand this particular remove method, hashmap dot remove method. Okay, what we are passing is we are going to pass the key. So again, now again I'm going to give as a key 20. So we'll see here what exactly it will do on this. We'll identify what exactly the remove method is internally implemented. Okay, now understand here, this is the remove method. Now observe, for the remove method also, what we are doing, we are generating the hash code and we are calling the remove node. We are calling the remove node method. So what you need to understand here, this is the remove node we are having, and here, so first again if you observe carefully, this condition and this particular condition same. Same means get node and remove node conditions are same. Remove node and get node conditions are same here. Now after that, what we are doing here, we are checking the key, hash code and key, everything we are checking. So we are passing the node and this particular node. Okay, here we are going to do here. So here, this particular condition, it is going to remove the particular object here. So this is we need to understand here. Now what we are doing is, so now we are going to check the node not equals to null, matched value something we are checking here, and here you can see tab index node not next here. Node dot next. Okay, if the node contains any next record, it is going to be passed. Otherwise, the node will become also 0. So this is what we need to understand here. So simply here, so while removing also, generating the hash code, and we are loading the particular record. So once we load, we are going to identify the index location. So now the index we are going to be removed. Okay, the index we are going to be removed. So this is what we need to understand here. So now we understand. So finally, we are going to return the E. So what is the E we are going to get? Finally, empty, like it is a null here, because the key 20, it is not available. The key 20, it is not available here. So now if I'm going to print this, so simply it will try to return as a null. Okay, null we are getting. So the record is not yet deleted successfully, because based on the key, there is no record inside this particular hash map here. Okay, so these are the today's session. So we'll continue tomorrow. So we'll try to discuss about the remaining methods. So what are the remaining methods we are having, like key set method, value method, entry set method, and off method. So these are the methods are pending. We'll continue tomorrow. Okay, so mostly we'll try to discuss about the the map. After that, we'll focus on the one more called the linked hash map and tree map. These are the two implementation classes we have. So we'll discuss in the tomorrow session. Okay, so we'll continue tomorrow.